Greetings, Rackheads. Dirk here, back to talk about hacking Rack. In today's visit to the lab, we're going to talk about a real-world problem. So picture this. You're hanging with some friends and you play VCV Rack as your instrument. They play traditional analog instruments. Take a guitar player. And you guys want to collaborate. So they start riffing, start throwing down some cool sounds, and they say, hey, give me some backup percussion. You can do that, right? And you're like, sure, I got sequencers, I got drum sounds, I can take care of that, no problem. And so you fire up VCV Rack, and you scratch your head, and you go, gee, which sequencer should I use? And then you drop the sequencer in, you wire up your clock and your outputs. And then it's like the guitarist is saying, well, play, let's play Twinkle, Twinkle, Little Star. Here's what it looks like. You just do this. And you're going, oh man, that's tricky because that's got 6 different sequences, 7 notes. And like, how are we going to do that? And what's going to sound right? And how do I iterate? And so you start programming. And like 15 minutes later, you got it going, and 10 minutes ago, they left because they were frustrated because they can play their instrument in real time. They can iterate in real time. And sometimes that's tricky in VCV Rack. So here's a practical example of how one might work around that in the context of sequencing. So let's get started like usual. I'm going to fire up my lab tools. I'm going to fire up VCV Rack. And I want to talk through the scenario a little bit. So imagine you're going to jam together and you need some kind of mechanism to exchange ideas. And they need to be what I call easy to reason about. I like to think of the 10-second rule. I should be able to look at my idea and in 10 seconds or less fully understand it. Right? Now, that can be tricky. Imagine you're working with one of the awesome sequencers in VCV Rack that let you sequence incredibly sophisticated sequences of sequences. But you can only see, because of the size, the HP requirement limitations, you can only see a portion of your song, with air quotes, at a time. That's not very easy to reason about because to figure out the whole sequence, you have to step through the whole thing, one chunk at a time, and once you go to the next sequence, you can't see the previous sequence, and it may or may not be familiar. Imagine showing one of the awesome sequencers in VCV Rack to a guitar player who's a guitar player, right? They kind of maybe use foot pedals, but boy, Euro Rack and virtual Euro Rack, that's just like, that is crazy. That's crazy. So here's how you might get along together. You might use a simple notation with things that they understand. So here's an example of, I want to do a couple of riffs. I want to do a C sharp, D sharp, and that's one sequence. And then my next sequence might be a G sharp, an A sharp, and a B. And it would be kind of cool if I could play either one of those sequences whenever I wanted to, right? Play them multiple times, chain them together, do anything I want. Now, a laughable real-world example would be something like, let's say our big hit song is going to be Twinkle, Twinkle, Little Star, and I'll refer to that from now on as TTLS. It might look something like this. And again, I'm dealing with regular people here, normal people. And so I want to specify both what the sounds are and what the lyrics are, because that helps us correlate everything. And literally, I can look at this Twinkle, Twinkle, Little Star, and in less than 10 seconds, understand what's going on there, assuming the basic understanding of what the letter C means or what the level E means and what sharps and flats, pound signs, and lowercase b's stand for. But that's pretty straightforward to get past with most folks. Now, I should mention that while we're capturing both note information in sequence and lyrics, I'm yet to see either a VCV Rack module or a Euro Rack module that I feed it lyrics and it sings to me. Maybe that's in development right now. I don't know. I'll buy that if that's coming out. Now, you could do some fancier stuff. For example, in Twinkle Twinkle Little Star, there's some verses note-wise that repeat, but the lyrics change. So here's a more advanced notation that somebody could implement that realizes that remember our slicing concept says that starting on row 2, 0, 1, 2, through, but not including 3, I want to repeat that one more time, but I want to change the lyrics to this time say, like a diamond in the sky. And then I want to repeat 0 through 2, the first 2 rows, twice, but I'm using the same lyrics. Again, I'm sticking with the Twinkle Twinkle Little Star, how I wonder what you are. Oh boy. Now, let's see how we might work with that. But first it's like, well, wait a minute, what if I'm not used to this kind of notation? What if I want to make it really obvious to the guitar player? Could I use guitar tablature instead? Sure. How about percussion tabs? Sure. Well, on a reach, what could you do? Well, you could use something like MIDI files. It might not be something that you can look at, but an expression of a musical idea that's in a pre-existing format. Any of those could be readily implemented. And you're going to see that I implement this in just a few lines of code here in the lab. So there's all sorts of awesome things you could do. I could sequence, in this particular case, I'd be picking a sequencer that placed sounds. I could also, with simple modifications, program sequencers that are gate or trigger sequencers. I could also kind of generalize this idea to be, I could express in a more human-readable format entire songs or expressions of something, and then push that into a particular module without much effort. So I could use the same strategy said another way to program like the chord sequencers in Rack. Again, a lot of times there's a correlation between richness and sophistication and, man, that's just awesome, cool with superpowers, and the need to program it, right? So that's what this strategy's all about. You could also do higher order things like not just program one module, but program that module and the 2 other modules that we almost always integrate into a patch alongside of that. So this same strategy could be used to manage that as well. So let's see how some of this stuff might work. Let me execute some code here. I'm going to start by, I've created a patch called sequencer. And so I'm going to go ahead and load that into the code. And then I'm going to talk through a little bit of background. In my example, we're using quasi-Western music note notation to express changes of tone over time, or note values over time, and to sequence them. So I have multiple notes in multiple sequences. So I have a couple of utility functions that help me do transformations from that world into my world. My world's CV. In Western music notation, we have 12 notes that we want to cast into 1 volt. So if you take 1 divided by 12, that gives you this magic offset that you would use for each successive note. Now, the next thing I have to cross-reference is these kind of goofy text strings, C, C sharp, D. I have 2 cross-references that allow me to calculate offsets or map from these letters into control voltages. And because I know each incremental level is the note offset, 1 divided by 12, if I know which note you are in the scale, I can just multiply like the 5th note 5 times that control voltage offset, and boom, I have that CV value. If I want to do octave shifts, that's just a simple mathematical change as well. So I've encapsulated that into this nice little function called toCV. And I go the other way. If you have If you have a note, you call 2CV. If you have CV, you call 2-note. And here's a couple of examples. 2CV from note data: C, C sharp, B flat, D, C3 down an octave, and C5 sharp up an octave and sharp. Now remember that for the sake of this conversation, middle C, C4 is octave 0. And so we'll negate to go downstream or increment that to go upstream. So you'll see that I'm printing out my CVs, and so the note C is 0, C sharp is 0.833, D flat is the same as C sharp, so of course I get the same number back. And you can see I've got several examples there. Okay? Now what we need to figure out how to do is convert this into CV. I got some for that too. So I literally just took that text, swiped across it, copied it, put triple quotes around it because that's the magic you do in Python. And then I can pass that to my parse notation function that I've created, this little service. And what it's going to do is it's going to print out the original notation. It's going to parse it into note data, throwing away the lyrics because we can't make use of lyrics yet. And then it'll also show you what it looks like as CV. So let's run this. And everything comes out as expected. And now I want to start to hack patches. So first thing I want to do is I want to show you what my patch initially looks like. So here's the sequence data, our sequence patch. Here we go. So we're going to start with the ever so loved phrase seq 16. And we're going to patch this baby. And we're going to do that simple, remember that first example I showed you? We're going to start with something that looks like this. Just something silly as a basic state. And we could have started with nothing there if we'd have preferred. We could have just said, we could have initialized that phrase seq and started it as blank. But if we play this, and again, not bragging on the quality of the patch. We can see it sequencing through the patch as it was specified in that first conversation. And so imagine the scenario where your cohorts, that guitarist, is saying, no. We got to change that to Twinkle, Twinkle, Little Star. Can't you do that? And you go, yeah, I'll be back and go get us coffee. I'll be done in 15 minutes, right? Or you could use some infrastructure that takes this and behind the scenes replaces the CV data that's built into this particular module as it gets saved. So let's go see what that might look like. So I'm going to open up that sequence VCV file, and I'm going to pull out the CV parts, and I'm going to just throw that out on the screen for you. So let me run that, and you'll see that as you look across, this is just the CV data. And remember with this particular module, this module is awesome. Remember, you can do 16 note sequences, up to 16 notes, and you can do 16 of those. So, and then you can do variations on how you iterate through those, and you can reassign those whenever you want. But the essence is you've got a 256-step sequencer. Now, knowing that, it's actually really easy to sleuth out what's going on in the file, right? They've got this section in the file that has all this CV data. And literally, if you look inside the file, it's in a section where they're defining the module. It's got a data section and a parameter section. We're looking at the data in this particular module. Others might store it in the parameter section, and we're looking at the CV data. Now, this is literally as easy as you might imagine. See the values here at the beginning in the first sequence? There's 4 numbers. And 16 notes later, the second sequence starts. And it's got some notes, right? So this is literally how 2 4-note sequences get programmed in this sequencer. So what do? Well, that's easy. We're going to patch that to use our own CV data that we generated from Twinkle Twinkle Little Star. So we're patching the patch. So let's patch that. Now look at our CV data. Where it used to say I had 2 sequences of 4 notes each, now I have 6 sequences of 7 notes. And it's patched all of that. It's patched the part of the patch that says, well, how long is each sequence? And it's put the data in the right places. So if you look at the data, remember, C is 0, twinkle, twinkle. Yeah, you get the idea. The whole song is there in all the pre-populated sequence slots. Amazing. Okay, so let's go back and give that a test drive. Now, this is Seek. I could have written that data into the same file, but I chose to open it into another file just so we could keep them separate. So here's Seek 2, and that was what I wrote to in that function. It looks the same, but the sequence is different. Now it's Twinkle Twinkle Little Star. And if I run this, see, notice the difference there. Now it's playing Twinkle Twinkle Little Star. If I want to go to sequence 2, I could either automate this or I can do it manually. So now I'm on sequence 2, and you'll notice on the keyboard that the sequence is different. This is the second subsequence of our song. I could continue to the third, I could continue to the fourth, and so on. So that was pretty cool. So now imagine you want to change your song. Oh, that's easy. All I have to do is go back to my specification here that I'm working on with my bandmates, tweak it in this section here, and repeat the process. And we patch a new version near instantly. Pretty amazing. So we went from this to a patched version of the sequencer in practical real time. So now we can finally keep up with those analog instrument musicians. Now, here's one other advantage we have. Not only have we documented or codified the performance, but we could use this generic specification to program a different sequencer within the constraints of those variations in the sequencer. So here's an example where I'm going to program another sequencer. I'm going to use AS's Seek 16 this time. Okay? And I'm going to do basically the same thing. There's just a little bit of difference because AS chose to store CV data in parameters and the other sequencer stored it in the data section. But super minor. You can see that the whole example complete with my docs here is only 16 lines of Python script, and that includes some blank lines. So let's see what that might look like. So I'll go ahead and run this while we're here. And you'll see that it's done some magic patching. Again, this patch relating to this module has a different format. So all we have to do is tweak the last part of our code a bit. But the first part that does the notes to CV, that does all that prep stuff, that's all completely generic. So let's go see what this might look like. So we're literally taking that same human-readable specification and we're casting that into a second sequencer. So let's open the second scenario. I open up my first reference file, and as you can see, this sequencer is initialized. See, all the knobs are set to 0. Initially it's set to 16 steps, and I could configure anything that I wanted to configure. Okay, and I would store that as my basic starting point. But now we want to do Twinkle Twinkle Little Star. Now, what's the first requirement or the first restriction? How many sequences can I specify here? Well, in this particular view, I can only implement 3. So in the other example, I was able to implement more, But in this, I'm just going to send through a subset of the song sequence notes. So instead of sending all those subsequences, I'm only going to send the first 3. So let's see what that might look like. Glance at the knob settings and see that everything's zeroed out. So let's open up the version that we just generated by looking at this and patching it based on that CV specification. Hoo-ah! You see all those knobs move? And notice its steps now is 7. So it literally, in near real time, casts that musical notation that was easy to reason about, past the 10-second rule, and we cast that onto this sequence in this more sophisticated chain with more stuff going. Pretty cool, huh? Now, if you wanted to, and this could also be automated, you could, since you know this has got 7 steps in it, you could take this and clock your switch. So if you knew you were going to have that sequential switch in the patch, you could go locate that, you could locate the sequencer, and you could make that patch. Based on, how would you know which of those plugins at the bottom here to plug into? Well, you know how many steps there are. You go to the corresponding value down here and wire that up. So anything goes. It's totally up to you. So this is an example of hacking Rack to solve a real-world problem. You want to collaborate with your bandmates, and they play instruments where they can generate noises in real time. Well, now not only do you have a communications strategy for working back and forth, but you can cast that into your favorite sequencer or other module with minor tweaks. And now you can perform known pieces like this in real time at the same velocity that they do. Pretty cool hack. And that's a wrap for today. Thanks for stopping by. Don't forget to like and subscribe, and see you for the next video.